Okie doke, round 3. So we've got ourselves a raster of our lobe. Now what we're wanting to find is for this raster what the distance to each pixel, or from each pixel to the center of this crater is. And that's going to help us calculate the velocity via a problem you probably did in one of your intro physics classes. This is something that's new to me. I've done spatial analyses before, but not necessarily this, so I don't know exactly the tool to use. I am going to just go in my search tab and search distance and see what comes up. I'm going to search distance raster. Maybe that's too much. Project raster, that's not what I want. IDW interpolates a raster. No, thank you. Let's go back to distance. I got more options there. Cost distance, that sounds expensive. It's giving me a little thing, right? Calculates the least accumulative distance, blah, blah, blah. No path distance allocation. Nearest source for each cell based on blah, blah, blah. No, these are sounding like they're doing things once I already have some idea or have a raster with some distance in it. I just want a simple distance. Can I get that? What's Euclidean distance? Calculates for each cell the Euclidean distance to the closest source. Well, I have no idea what Euclidean distance means. I'm going to go into the internets, and I am going to go to Google, and I'm going to type in ArcGIS distance raster. Because the distance raster, Harvard, what do they know? ArcGIS, Web Help, Esri. All right. Illustration. I like illustrations. Euc distance. That sounds good. Command line and scripting. That sounds like too much information. Do they tell us any more? Learn more about how Euclidean distance functions work. Y max, X max. Oh, check it out. It's a triangle. That's something I can understand. Let's go back. Let's see an overview of command line. Euc distance. Let's see what this says. This says the same thing. Now, I seem to recall an overview of the distance tools. Let's take a look at this. Path distance. What does that tell us? There is somewhere in this where there's nice pictures. Well, I'm bored and you guys don't have all day. So let's just go back and let's see what Euclidean distance does. A lot of times in ArcGIS, and this may happen with some of you in your DIY proposals, you can't always find the exact right tool for what you're doing. So you sort of just make up a tool. Or you use a combination of tools, rather, to achieve a task. Okay, so input raster or feature source data. Input source locations. This is a raster feature that identifies the cells to which the Euclidean distance for every output cell location is calculated. So the raster that it's producing, right? The Euclidean distance for every output cell. The output cell is the thing we're creating. The feature that identifies the cells or locations to which this is to be calculated. So this is the thing that I want to calculate the distance from, right? That's just a very wordy way of saying that. Well, we don't really have that yet, so let's go ahead and make a feature like that and see what we can do with this tool. So I'm just going to make a shapefile. I'm going to make it a point, and I'm going to call it my Euc distance. And I often call things test or TST when I'm just screwing around with them. Lets me know in the future that I probably want to delete that file because it probably wasn't exactly what I wanted. Otherwise, I would have renamed it as something else. Normal projection. Let's make it a polygon. Right? Maybe we're actually ejecting stuff out of sort of the whole crater, or this little central crevasse, possibly right here. Let's try that. So let's start editing. And let's make something for Euclidean distance to calculate the distance from. It's in our shape files here. Oh, you bastard. So it does not find that right now, so let's stop editing. This is this wonderful problem that's been happening to us all repeatedly. Let's see if I can find it in here. You distance test. What if I just click that? Still doesn't want to find it. That's just wonderful. Okay, let's go ahead and stop editing. Let's remove that. A lot of what ArcGIS is problem solving. And what we're going to do today is demonstrate some ways in which we can solve problems. I'm going to call this tests now because it's going so smoothly that maybe I'll need more than one. And I'm going to find that Euclidean distance tests, and I'm going to put it up in that folder, and then I'm going to bring it in. Close out of my catalog here. Come on, go away. Editor, start editing. Let's try again. Yay, there it is. Alright, so now I'm going to go in here, and I'm going to find this sort of central crevasse, and I'm going to go ahead and make the null hypothesis that that's where the ejection happened. So I'm going to sort of outline that thing like this. Great. And I'm going to stop editing. I'm going to save those edits. I'm going to open up my art catalog, which I minimized earlier. I am going to not open up my art catalog. I'm going to go back to Euclidean distance. And I am going to use that. I'm going to make some shapefile. I'm going to put it in my tests. Euc dist T1. I'm going to go ahead and make the assumption that this is going to take more than one try. Definitely don't want an output cell size of 1/4 of a meter. Max distance, let's see how far we can go with this. Output direction raster, don't have that. I want in all directions, although all directions from this, within this area, is pretty much only going to be north-northwest. Okay, let's see what just happened. Okay, well it's done, but I don't really see anything. If we zoom in here, we made a very tiny raster, and indeed it has some values that look like they could be distances. Let's go to the measure tool, and let's see sort of what they are. Are they from the center? They're not from the center, right? Because I just got 154 meters, 160 meters from the center to the edge. Maybe what they are is the distance from here to the edge. That's 37 meters, right? That could be, that's actually like the max distance sort of within this raster. Now, unfortunately, this raster is only as small as this shapefile is, right? I made the minimum size raster. If we go back to Euclidean distance, maybe there's somewhere where we can specify how much the area that we want to travel over. Where were we? Euclidean distance. Output distance raster. No, that's what we're making. We want to input some other raster that would tell us about, that would tell our GIS over what area we wanted to calculate that, right? That would be one way. Or we can take a shortcut. Maybe this is a long cut. If this just made the smallest raster it could make to include the distance to this one shapefile, maybe we can just make more shapefiles that would increase the distance, right? So let's go back to our editor. Let's click Start Editing. And let's make up some Unreal things here. Let's like put one over here. And it's gone, but it still exists there, right? It's just disappeared because of the layers that I'm actually displaying. If I click No Clipping and apply here, you'll see that that comes back. Let's go ahead and stop editing. Save our edits. Let's try another Euclidean distance test. Eucdist. Oh, we do not want to be saving to this location. That would be bad. One of these tests might actually come out being useful. Oh, notice how it's giving us more cell size. That's interesting. Let's click OK. Oh, look at that. made our raster a little bit bigger. Now, though, you'll notice while there's these values that appear to be radiating from both of our points, right? And if we click on our identify tool and click those values, they're giving us something like 442, 480 for this orange one, 300. Let's see, that's going to correspond to a distance, yeah? Yeah, about 300. Great. So that seems right. The problem is, it seems like I might have made what I want, right, is the distance within this polygon, or the raster values within this polygon, to only be distances away from this source area, right? This I just made up as a shortcut to getting this tool to do what I want it to do, and it seems like it could be interfering with some of my tip distances there. So let's go back to editor. Let's click start editing. Let's select distance again. Let's click this thing and let's delete it. And let's do something else that's farther away. Now, when we do this, we want to make sure that we're going to have enough lateral extent that it's still going to cover the whole lobe too, right? It's making the minimum rectangle that it can. So we want to put something out here, but we also want to make it wider than we need. We just barely made it there, right? So that our lobe is within, or our lobe is within the raster that we created. Yeah, that's what I wanted to say. I realize this all must seem a little bit vague and confusing, but a lot of times this is how things work, right? You're sort of just trying stuff out. So let's make another raster out here. Let's make it farther away from our thing. Let's make it nice and wide. And let's click Save Edits. That's what we're going to click. Let's stop editing. And now is as good a time as any to save our map and go back to Euclidean distance, input that same feature, change where we're going to output it to. I'm going to go ahead and be confident and just call this distance final. I'm going to capitalize it because I'm just so enthusiastic about this working, because I think it's going to work. And output cell size, let's say 10. One thing that I have not brought up but is important is when you're doing spatial analyses, right, you're going to be doing a lot of calculations on DEMs, and it's good to keep your DEM size the same, right? If you do operations with multiple DEMs, you're always going to take the resolution of your lowest DEM. So keep things the same when possible. And let's click OK. And let's wait patiently. And look at that. We now have this nice raster, this beautiful rainbow of data that includes our lobe, just like we wanted to. And it also has distance values, right? We see those distance values. It has some extra material, but we can deal with that. And you can really see what's going on here, right? Each pixel value, the shortest distance to that pixel from this place we're saying it's being ejected is a straight line, right? So things sort of radiate out from our features there, and you can see things radiating out from here too. Great. Well, that's a good stopping point if I've ever seen one. So let's go ahead